I really do want to start with this interwoven relationship of the more historic approach to thinking about photography. Camera obscura has been around for a long time. There are records of how it worked in lots of different places. Now, I just want to talk about what the camera obscura is briefly. Basically, it is this idea of a darkened room. You can imagine this happening almost accidentally in the real world. If you have outside and then inside it's all closed up, maybe shutters are drawn, and through the shutters there might be a tiny hole. All of the light from that darkened room goes through the tiny hole. It's creating a reverse upside down projection of what you see outside. This is optics, physics, how light travels and what happens. It can be done without a lens even, right? So the word camera obscura is actually the Italian word for room, which is camera, and the word darkened, so oscuro, so camera obscuro is a darkened room, which is, I think, really funny about the language, because in Italian, a fotocamera, but they would usually say a macchina photographic machine, is because they're not going to use the word camera because camera means room, right? So it's a different thing. Similar to, in German, they say Fotoapparat, which is basically saying a photographic apparatus, not a camera, which is the language that we use. In English or French, it's very similar to the German. I don't speak French, so appareil photo is basically saying a photographic device. In Spanish, it's similar to using the word camera.
So what exactly is this device, camera obscura? It's essentially a system of lenses that, in a darkened room, projects an image of the outside world into a dark box, an early predecessor of the modern camera. The process is quite simple. Rays of light enter the darkened chamber through a convex lens on the front of the box when pointed at the outside scene. This projects an inverted and reversed image onto the viewing window at the back of the camera. The resulting image shows unique optical effects, including diffused or soft highlights.
What motivates us, specifically in this time in Western art, to really want to depict reality of some sort, or a picture of reality. There's this interesting shift that happens where there is a great need to capture what is otherwise fleeting moments in the world and capture it as real as possible. This was very much happening with the camera obscura, and that's something that lends itself to Vermeer's work, because there was a lot of emphasis on light and dark areas of the Northern Baroque. There were other devices. This was much later. There was 1806 the patent for the camera lucida, which is basically doing exactly what we just said that the camera obscura was not doing, which is a device to actually guide your hand in drawing. This was a mechanism created where you would be able to get a mirror image projected onto, for example, a drawing surface where you could copy from nature. Anyone can buy one of these at an art supply store, a camera lucida, which is simply a projector. It's doing the same thing, allowing you to trace what you see through this light projection. Kepler actually commented about this, but there's no proof that he actually made one but understood how the physics of it works. So this is the actual first patent. Our story in terms of photography really starts with silver. Johann Schultz was playing around with some chemicals in his laboratory and realized that silver nitrate that was mixed in a jar on the shelf, when the sunlight hit it, half of it was dark and half of it was light. And he was trying to figure out what was happening. Started playing around with that a whole bunch, and then realized that basically by mixing silver with salt, so silver nitrate, he was doing things like putting them in different jars and was assuming that it was the heat and temperature affecting the light and darkness. But then when you shake it up, the salt crystals would mix and it would turn light again and repeat. What he was doing is putting it in a jar, labeling it, and then realized when he pulled the label off that was written in black, it remained white because it was light sensitive. So then basically the person notable as establishing the light sensitivity of silver nitrate, that it gets dark in sunlight. So this is still years before photography was developed. There are other people who wrote about silver nitrate and how it had this effect of darkening, talking about how long it would take for a year before it would fully turn black in sunlight, and so on and so forth. This is one of the fun parts of science. The reason this guy, Schultz, is getting credit for it is because he published what he discovered. These guys didn't. They wrote about it. It was in their journals, in their notes, but not published. This naming and this idea of what happens in science is the ability to present something as that you are recognizing some discovery has to be published to get credit. This idea of credit will come up again in a few other things. So this is another guy that we've seen him before, Scheele, which is this chemist that he is remarkably known for what he discovered, but no one figured out until years after it could have been used, which was this idea of a fixer. So if you've ever done analog photography, after you affect the paper with light and you put it into a fixer, it's going to hold the color or the light from moving. He figured this out with ammonia, that the metallic particles would stay, would hold, would be fixed. But there were lots of other things that happened after this discovery before they actually started creating fixers, which is what we currently use. The other thing that he discovered, that the red light does not affect the exposure because it's a different wavelength. That wasn't used until years after, when we started creating darkrooms. And that's why you see red light in a darkroom. You could still see, but you're not exposing the camera. So just to give this guy a whole lot of credit, Scheele's green, which was this green made with arsenic, killed lots of people. There's the theories about that that's what ultimately killed Napoleon, because he had green wallpaper in his room. He's also recognized for discovering oxygen before Joseph Priestley. The difference was he didn't publish it before Priestley. But these are a bunch of other things that he is recognized for discovering as a chemist. So really interesting. And of course, arsenic acids. So moving forward with the science, you had a lot of people at this time, late 18th century into the 19th century, that you have the beginning of the Industrial Revolution, and a lot of people, the age of discovery and age of inquiry, and there were lots of people, even, let's put it this way, wealthy people without needing to have a job, but were investigating all of these fun tools that they had. And this guy, Wedgwood, if you're familiar with the name, Wedgwood is a specific kind of pottery, so a ceramics or porcelain that is you see in a lot of fancy plates, right? This was their family produced these Wedgwood porcelain. Some people call him the first photographer. He created these things called photograms, where basically what he was doing was he was taking this image, coating it with this light-sensitive chemical. When I say silver nitrate as a light-sensitive chemical, there are lots of variations of that. So it's light-sensitive compounds made of silver and halogen. It could have been mixed with different things that they were all experimental. But ultimately what it did as this photogram is this idea that you take an image, lay it down on a plate that's been covered with this photosensitive material, and you put it out in the sun for a while. When you pull it off the leaf, you have this image that remains. Now, what that would also require is you realize that the dark areas have hardened, the light areas are still soft, and then they would basically wash off those extra chemicals, which is this idea of the fixing, which is something else that develops further as we move through this discussion. So, moving forward, you have this guy, Joseph Neisp. He's one of the people known for making the first, what we would call, photograph, different than the photogram, which was not done through any light surface, but this was using a mechanism similar to the camera obscura with a heliographic plate that was this plate that was light sensitive coated, put on the back of this room, this box, this camera, and set it up at his window all day long, like about 8 hours, and then gradually those darkened areas would harden. Some areas would harden and the other ones be soft, and then he came up with this image, which is basically, this is the first image, the first photographic image that occurred. Just to give this inventor playing around with the science a little bit of credit too, him and his brother were the first people to create a combustion engine, which is pretty interesting as well. But the other thing that I just want to point to is the date he died, 1833, bitumen of Judea, which is what's used for asphalt, which was the coating that was becoming light sensitive to make these pewter plates, or sometimes copper plates, that were used by this guy in conjunction with NISPA to work out what was really the first commercial photography. It was this guy, Daguerre, and that was him taking this photograph, similar system to what Niepce was using, but he was doing it on this copper plate coated in basically asphalt, tar, that then hardened, and you see this image out of his studio. And the thing that's interesting about this piece, this was 1838, this was one of the first images of a person, because the exposure time took so long. It was, 8-9 hours. No one was going to sit still for that long. But in this case, they were speeding it up with different chemicals, different mixtures, different nitrates. Taking this picture out of his window, it happened to be that this was a location where there was a shoe shine. There was always one person standing in the same position for an extended period of time. So that captured this guy, which you could see barely out of that image. But these were still very long exposure dates. So this guy, Daguerre, he was more of an artist, actually a set designer or stage designer. He was very involved with creating these interesting backgrounds that had this translucent light. When it's light inside, dark outside, you can see in. So he was using that in his stage sets, where it would change from night to day based on where the light was placed. That experimentation got him into contact with this scientist and started working out this other process with these copper plates and this asphalt. The interesting thing is, you might be familiar with his name, but he didn't actually patent this or start producing it and named it after the other guy. Remember I said that he died in 1833, and this image in 1838 was known as the first daguerreotype, based on this guy named it after himself, even though he didn't really found the science behind it, but he definitely promoted it. They were creating these stores all over the world. In France, there was dozens of them. In New York, where you can go in and sit for a photo, and you would have this one plate that would be light sensitive, and there was this whole process. And here it talks a little bit about what the process is. The copper plate was polished, coated with silver, exposure to iodine vapors, created this light sensitive silver, and the exposure in the camera formed this latent image, this hardened image. The developer typically used a mercury vapor to convert the silver iodine to create the positive image, the mirror-like surface. So this is basically the process that was lots of chemicals involved with it, which is interesting because they used there was full teams of people that were developing one photograph, and it wasn't called a photograph back then. One of these daguerreotypes, it was a whole team of people, and they were using a lot of chemicals, one of them being mercury. Have you ever heard of the Mad Hatter? Hatters, people that made hats, used mercury in the 19th century. The edges of hats would be turned up, and they used mercury vapors to create the forms. Too much mercury exposure affects your brain. So interesting. This is basically the process of the daguerreotype. This is really the broadening of people, because they were this opportunity for people to go and have this one unique photograph. The difference here is it was one of a kind. You sat, the light hit you, it landed on this plate, it hardened, it was cleaned up and polished, and then handed back to you. That was it. One picture. You don't get duplicates, right? So this is really one of those key things. Until this guy, William Fox Talbot, created a different version, which was ironic because he was doing this at the same time the daguerreotype was happening. This was in the late 1830s. Now the difference with what Talbot was doing was that he was creating a paper, he was basically putting salt and silver mixture on paper, and then using that, the original ones, basically doing the same process that Daguerre was using, but this image that was etched in was in reverse. It was the negative image that was being washed away. He was basically creating the first printed forms of negatives, then able to reproduce them. You can take this negative, you can always produce another one. The difference is that it lacked the crispness of the original daguerreotypes because it was light being shot through paper. There's this fuzziness of the paper because that was the filter. The film being used was paper. To give you a sense of this calotype, which is this silver-coated paper, the word comes from kalos, beautiful, and typos, impression, so this beautiful impression, which is still a common term, this wet plate process. Then you have John Herschel, which basically was the first one to fix an image as opposed to having this temporary nature of the medium. But he's the one, John Herschel is the one who first coined the term photography. So that wasn't until 1839 that he used the word photos, light, and graphie, basically saying that it was drawings of light, which is still the beginning of what I was talking about, this relationship between copying something, drawing something, making something that was capturing a moment. The interesting thing with this sodium fix that he made this prints a little bit more permanent, he was also the first person to start using this idea of the negative because he was using this other process that was creating the negative, and then also created his own printing system that was the cyanotype, which was later to be called a blueprint. This is the guy who basically invented the blueprint, which is the same basic chemical process. So in the 1860s, you had more and more photographs of people. This is a very early picture of Lincoln before he was president, where he's actually without a beard. Right? So this photograph is what got him elected, because it was the first time where people could actually read one of his speeches and see the image in a newspaper or wherever it was printed. That had a huge impact, which is interesting because this is something that consumed the 20th century in terms of image and the photographic relationship. Some of you might know this with John F. Kennedy and Nixon, the television debate consultants that Kennedy had him wear a blue shirt, not a white shirt, because on black and white television, which is where everyone saw, the white was going to read as a gray, and it would be a bad contrast for the skin, but a blue shirt tones it down, it's different. Light translates to a bright white shirt on black and white television, which had a huge impact on the way people saw him. The photographic image of people is brand new compared to paintings. It also had a lot to do with, in terms of the use of the daguerreotype, that they had these stations set up all over that anyone can go in. I think it was something like $38. That was still a lot of money, but you can get a picture of yourself or of your loved ones or your family. It was not like a quick snapshot. This was widespread. even if it was expensive, $38 then, a month's wages, it was much less expensive than having a painter do your portrait, which was much more expensive and more time consuming. It's also significant to how it was used at the time of the Civil War, for example, the photographic image and how that was related to media and images that people were able to see the horrors of war in pictures, and also relating that to families, and also using photography as a keepsake, something that you can take pictures of people, so as a soldier before they go off to battle. But that leads us forward into Kodak, right? So George Eastman very much was pioneer in developing these, but it was just the technology that already existed. It was this dry plate film that was used. You press the button, we do the rest. When you went to one of the studios, you would have a whole bunch of people, you'd take the picture, it would take forever. This was much faster, this idea of the camera, the room, the box, the camera obscura, right? But it was all, there was a shutter, right? This idea of where the light comes in. It was all automated, much faster. The exposures were faster. Everything was faster. This was preloaded with 100 pictures. All you needed to do is take the pictures, press the button, and then send it off to Rochester, and they would develop it and send you back the prints. This is a whole new world opened up with the Kodak camera. The word Kodak is really just, as far as I understand, just something that George Eastman invented. It's not based on, like a lot of these other ones, which is a lot of reference to mythology and the roots of Western culture in the Greek language, and a lot of that is used in photography and all the names of a lot of these other things that were built. But this one was just invented, which is fun. Then we have this guy. This is kind of fun. Leland Stanford, who was the governor of California and the founder of Stanford University, and rich guy, executive of the Central Pacific Railroad, and significant shareholder in Wells Fargo. So here he is, a super rich guy. He had lots of horses, big stables. And there was an argument about, is there any one point where a horse is at full gallop that all four hooves are off the ground? And many people said, no, not a chance. He wanted to prove that it was possible for such a big, heavy animal to actually not be supported by at least one leg. When horses are moving slowly, you always see that there's at least 1 foot on the ground. But when they're running quickly, it's too fast for your eye. So he hired this photographer, Muybridge, to work out a system where he had his horse run by, and it was set up with all of these tripwires, and those tripwires are connected to all of these cameras that are basically going to push the button on the camera as the horse ran by. So we'd be able to catch that moment when the horse was in full gallop, and potentially all four were off the ground. So you see in number 2 and number 3. The other part of it was he redid this process with a bunch of different horses. Something like what you see here, this Horse in Motion, was published. The first time around it was questioned because you see that it's in silhouette. So there was accusations that it was hand painted, right? Not a photograph, because it looks like it's hand painted. And then they redid it with different shutter speeds and better cameras, and then this is basically what you have. So these are all still images that are then put together. These, you can see the 24, which is interesting because it leads to this, where we're going to go, which is 24 images per second is what you need for a motion image. So at that point, there was no sense of having anything more than just a still photograph. It was already fantastic that it was capturing reality where nothing else was really able to do that. But then they pushed that forward a little bit, and Muybridge, there was this zoopraxis scope where you basically were able to focus in on one of these multiple. This is all based on what Muybridge was doing, taking these multiple images and seeing it in what we now know as stop motion. These discs were happening. which then push that forward a little bit more, and then you have the zoetrope, which is really fascinating. It's basically creating this sphere with all these circles in it, and where you're looking between the individual slots at those still images, it is in motion. The fascinating thing for me is when you're looking at this lower one, it's going backwards. But when you look at the upper one, it's going forward. It's basically the way your brain is registering motion. This is just one example of how it works. These zoetropes, look through the slot, spin it, really quite simple. So that brings us forward to this guy's sneeze. We're still dealing with photography at this point, but then this interesting experiments that were happening with Thomas Edison. This guy is actually this Fred Ott is one of Thomas Edison's assistants, and they built this thing called the kinetope. Basically, this device would run still images just like what we saw, and there's a little eyepiece at the top. Instead of it running in a circle as the zoetrope does, you're looking down, and it's just running the individual pieces of film in a cycle, and you're watching it happen. This was the first motion picture, only 15 seconds or less. It's basically this guy sneezing, and it was fascinating for lots of people. We're only talking from 1840 to 1894, that short period of time from the first photograph to motion photos. That brings us to the end of the 19th century with the first film that was actually produced, shown, and people paid to come and see it. So the first cinema. And that was done by the Lumiere brothers in France on December 28th, 1895. And that was the beginning of cinema, the idea that it wasn't just a scientific experiment that people saw. All this film was that people came and paid to see were people leaving the Lumiere brothers factory. And that's what this image is. It was very short, but people came to see it because it was fascinating to see moving images. No painting ever did that before. Part of it that I want to talk about is this relationship to us and photography, and the difference between a story, which was just portraying a certain narrative or documenting something objectively